This video is sponsored by Brilliant. We're going to start our problem with a right-angle triangle with the legs of 24 and 7. Then, inside this triangle, we will inscribe 3 congruent circles. And the question is quite simple. Can you somehow calculate the area of those 3 congruent circles? And a big shout out to my subscriber John, who sent me this awesome problem. And if you guys want to try this one out for yourself, you can pause the video right now and then come back and check the solution. Alright, so let's solve this one. So first I'm going to label all 3 vertices of our big right-angle triangle as A, B, and C. And I will also label 3 centers of our 3 congruent circles as O, P, and Q, as you can see on the sketch. Now, first we can notice that we have a right-angle triangle and that we don't know the value of the hypotenuse. So we can use the Pythagorean Theorem to calculate the hypotenuse BC squared as the sum of the legs AB squared and AC squared. And we can substitute our values from the sketch. We can work through this and get that BC squared equals 625, which means that BC equals 25, and let's implement this value into our sketch. Now, let's take a look at our image once again, and let's do something really interesting. Let's connect the line AO, OB, and OC. You will see why I use those specific lines later, but first let's label the radius of our circle on the right as R. Of course, since all 3 circles are identical, or congruent if you like, this radius will be identical for all 3 circles. Alright, so now let's take a look at this radius, and let's rotate it to the point of contact with the line BC. If we do this, we can use a tangent of a circle theorem, which states that if we have a circle and if we connect the radius of this circle to the point of tangency, then the radius will always be perpendicular to the tangent line. So, in our case, the line BC is a tangent to our circle, which means that the radius R must be perpendicular to it. Now let's take a look at the triangle BOC. Since we know that the area of any triangle equals to the half of the product of the base and the height, we can say that the area of our triangle BOC must be equal to the product of the base, which equals 25, times the height, which equals R over 2. Great, so now let's simplify our image and let's rotate our radius once again, but this time vertically down. And now we can again use the tangent of a circle theorem, since you can notice that the line AB is now tangent to our circle. So this means that our radius must be perpendicular to the line AB. Again, let's notice another triangle. This time the triangle AOB, and using the same logic we can write down the area of this triangle as the product of its base of 24 and the height of R over 2. Now, once again, let's clear our image, but this time let's have a look at the circle on the far left. Of course, this circle will also have the radius of R, and if we pull this horizontal radius to the point of contact with the line AC, as we did on our sketch, you can notice that again our tangent of a circle theorem applies, and this radius will be perpendicular to the line AC. Alright, so now finally, let's label the radius of our circle in the middle as R once again. And let's rotate the radius of our left circle to the point of contact with the radius of our circle in the middle. If we do this, we will get the straight line QP. We know that this is a straight line by using two facts. The first one is that all three circles are congruent and all of them are touching the horizontal line AB. And the second one is by using a theorem which states that if two circles touch each other, either externally or internally, then their point of contact lies on a straight line joining their centers. And as you can see, this is exactly our case. Now let's focus on a circle in the middle and let's rotate its radius to the right. And now finally let's rotate the radius of our circle on the right to the contact point with the radius of our circle in the middle. Again, by using the same logic and the same theorem, we can conclude two things: that this blue line must be a straight line and that this blue line is actually perpendicular to the line AC. So now if you take a look at the triangle COA, you can see that we actually have its base and the height. The base is 7 and the height will be equal to 5r. So we can write down its area as 7 times 5r over 2. And moments like this are exactly why I like going beyond just watching solutions and actually practicing problem solving in a more hands-on way. This is one of the reasons I've been using Brilliant. Instead of just explaining concepts, it gets you to actively think through them step by step, which actually really builds your intuition. What makes it stand out is that everything is interactive. You're constantly solving, testing ideas, and getting immediate feedback. For example, their courses on things like transformation or algebra connect really well with problems like this, where understanding the process matters more than just getting the answer. Their courses are created by educators from MIT, Harvard, and Stanford, and they are literally designed for everyone, from age 10 to 110. And it's not just math. They also cover coding, logic, and even AI, so it's a full problem-solving platform. So, since Brilliant is sponsoring this video, you can get 30 days for free using the link in the description or the QR code on the screen, plus 20% off an annual subscription. And that is a really neat deal. Alright, so let's go back to our problem and let's clear our image a little bit. And let's also remove all three circles for now. You can notice that our triangle ABC actually consists out of three triangles, the triangles BOC, AOB, and COA. So we can say that the area of the entire triangle ABC equals to the sum of the areas of those three triangles. But since we already got the areas of those three triangles, we can just implement them into our formula. Now we can work through this, and you can notice that all three fractions have the same denominator, so we can add them up. And finally, after simplification, we will get that the area of the triangle ABC equals 42r. Now, there is another way to obtain the area of this triangle. Since it is the right-angled triangle, we can say that the area equals to the half of the product of its legs. So, in our case, 24 times 7 over 2. We can work through this and get that the area of our big triangle ABC equals 84. Now we have two values for the area ABC, so we can say that those two values are equal. And from this we will get equation from which we can easily get that the value of radius r equals 2. Now remember, this radius represents the radius of one of our circles, and we can easily calculate the area of this circle as pi r squared. But we have three of those circles, and all three of them are congruent. So the combined area of those three circles will be 3 times pi r squared, and we can substitute the value for r. If we do this, we will get the following. And after an easy calculation, we will get that the area of all three circles equals 12 pi, and this is our solution. Alright, so if you guys enjoyed this video, don't forget to leave a like or subscribe to the channel. Also, if you found another way to solve this problem, please write it down in the comment section below. And until next time, as always, see you guys and take care.